Hello guys, welcome back. We are gonna go back to triangles, and here is isosceles triangles. So just by definition, an isosceles triangle is a triangle in which two sides are equal in length. So basically, for example, if you have this triangle, two sides, that calls basically two legs, all lateral sides, they should be the same. So we mark them with equal marks, and that means they're the same. All right, so this is the base of an isosceles triangle, and in this case we have apex opposed to the base, so it's on the top, and so base angles, they also should be equal, but this is sort of isosceles triangle theorem. Okay, let's go straight away to read the isosceles triangle theorem. In an isosceles triangle, we have the following. Base angles that are marked as alphas, they are equal. So in other words, we can say that angles here are the same. And the line joining the apex to the midpoint of the base, so midpoint is here, sort of median, right? And of the base bisects the vertical angle on two equal parts. So bisect means it splits the apex angle on two equal parts, each of beta, and meets the base at the right angle. So basically you can say that if you put a height in an isosceles triangle, height with 90 degrees angle to the base, it will bisect the base on two equal parts, basically becomes the median, and also it splits the apex angle on two equal parts, beta and beta. Okay, so the main properties here, the following properties of the outcomes from an isosceles triangle theorem. So first, property 1. If a triangle has two equal angles, then it's an isosceles. So simply to say that if we have two angles, alpha and alpha, that's called actually base angles at the base, and if they're equal, we have triangle to be an isosceles. All right, so by definition, we simply need to prove that those two sides are equal in length, and in this case, it becomes an isosceles. All right, so let's consider two triangles. I mark them A, B, C, and some point. Let's say, where is the base? I put a letter D here. Okay, so we have two triangles. First of all, we have triangle two equal angles. We have 90 degrees angle. We have simply another angle that actually is bisected by BD. So because BD in this case bisects the apex angle, and that's why so two triangles becomes isosceles. So two triangles A, B, D becomes the same with triangle B, D, C. Okay, so simply because we have all three angles the same, this is common, so two segments AD and DC will be also equal, and we have also 90 degrees angle and two angles alpha that are actually also the same. So we have the congruence of triangle ABD and BDC. So that's why we have AB equals BC, and that's why by definition this triangle ABC becomes an isosceles one. All right, so next one, the angle bisector of the apex of an isosceles triangle bisect the base at right angles. Okay, so let's see, we have the angle bisector. So the angle bisector of the apex, so simply to say we have two equal angles, better and better, and of an isosceles triangle, so simply to say that this side is also the same as this side, and we have the base, it also bisects the base at right angles. So let's mark it A, B, and C, and some letter D. So we need to prove that AD, isosceles triangle, bisect the base at right angles. So AD equals to DC, and also that angle ADB is 90 degrees. Okay, so what we have here, we have the following. So if two angles better and better the same, so beta alpha correspond to beta alpha in the second triangle, and we also have two sides equal, so we can prove that two triangles are congruent. So triangles ABD simply congruent to the triangle BCD, and hence what we figure out that automatically the angles becomes the same. But what if we have a straight line or the segment AC, we have the point D from where we have a line, let's say it goes to the apex, this is the apex point, so, and we need to prove that simply this angle X equals angle Y. So we've already proved using the congruence, but in this case we need to say what's the measure. So obviously if the total measure the same, total measure of the open angle ADC, so angle ADC is simply 180, so simply 2x, split this measure in two equal parts, so 1x is simply 90 degrees, and hence we prove that. And we also prove because triangles are the same, congruent, so those two segments AD will be equal to DC as well. Alright, so property 3, perpendicular bisector of the base. So we have perpendicular bisector, so bisect the base of an isosceles triangle, so means we have two sides equals, pass through its apex. Alright, so A, B, C, and D. So we can assume that in this case we have a contradictional statement that, let's say, it goes not through the apex B. This is apex. Maybe it goes through another point. Well, in this case, we'll have probably the following. So if we have two triangles, let's consider a triangle ABD and triangle BCD. What we know according to the statement. So first of all, that sides AD equals to DC. Also, we have sides AB equals BC. And we also know that because according to, let's see, the previous statement, if triangle has two equal angles, then it's isosceles. So if two equal angles, we have that triangle is an isosceles, so counter statement is also fair. So that's why this alpha should be also as another alpha. And we also know that this angle is 90 degrees. So we have two equal sides, and so two equal sides, let's say, and the angle between them. We also have one side is common. So basically we can say that three sides the same, so all angles should be the same. So here better and here is better. So that's why according to the statement, according to property 2, the angle bisector of the apex of an isosceles triangle bisect the base at right angles. So that's where we have 90 degrees angles. And in this case, according to definition of what bisector perpendicular is, so we simply can restore that we have, just remember how how to build this bisector. So we use simply two circles with the same radii. So simply here and here. And those two radius going to be the same. So in this case, this point becomes a point B of the triangle, and this is apex. Why two radius the same? Because we know that AB equals to BC, simply. And we also know that the perpendicular bisector should split the segment on two equal parts. I see. So hence, there is no way otherwise to go through the apex point. It will actually intersect with AB and BC in one single point, where exactly two circles meet each other. Okay, so that's property 3. All right, so that's it. That's all about proof. That's all about isosceles triangles. So hope you enjoyed. Try to use those properties. So feel free to apply whatever problem you have, and just try to apply also not only to triangles but probably to other topics and problems which somehow connected and which somehow involve those properties. All right, thank you guys. Goodbye.